Great. Good evening, everyone. All right, so that spot used to be there is not there anymore. I wonder why. But let's continue nonetheless. So, good evening, everyone. Welcome is in order, and thank you for joining. Yes. Welcome to everyone. Those who are new, those who have been here from a long time. Let's get with it. Of course, we are working with the equation of a straight line, and we hope to finish that topic today. But after that, we have quadratic graphs and straight line graphs that we need to get done in a few. So we'll continue with this topic this evening, and hopefully we can get it out of the way. So do not forget, and I'm going to say it again and again and again, that Tuesday class is an accelerated class for students who are doing the examination in January. Everyone can join, everyone will learn. However, this class is specifically for those who are doing the examination in January. Let's go. Somebody please remind me of the last thing that I did in class. I'm going to give you a multiple choice and you'll tell me. So, it is either we were given 2 points to find the equation of the straight line. We found the equation of the straight line, or we need to make use of the parameters. Did we use the parameters? Where we say that y2 minus y1 over x2 minus x1 is equal to the gradient is equal to y1 minus y2 over x1 minus x2. That's one. The length of the segment is equal to the square root of x1 minus, use x2, x2 minus x1 all squared plus y2 minus y1 all squared. And the midpoint is the average. The midpoint is x1 plus x2 over 2 y1 plus y2 over 2. Did we do that? Say yes. We did. I'm sure that we did. Did we use these formulae in a previous class? Anyone? Not last week because there was no class last week. The week before. Did we use this formula the week before? Good evening. Yeah. Come inside. Yeah. What are you here for now? Sure. I can't tell you. No, did you okay, the only one that I can remember for today is somebody who's supposed to collect the books. Are you the one supposed to collect the books? I can't tell you. Alright. You're the one who attend our seats? Okay. No, you cannot attend class because you want to leave here day in the middle of the night. You want to leave here like after 8:30 or so. So, I think that what you really want so is for maybe for me to show you what you need to do to get on. Alright. No, do you have TikTok? Yes. Just download TikTok. Alright. So I asked this, good evening. Yes, good evening. I asked the class a question, if we use this family already and no one will answer. Don't worry, you don't have to answer. If you answer, it is in your best interest, not mine. Because when I go to the board and start working, if it is not at the same place where you should be at, you can't stop me. So I'm giving you the opportunity to tell me where I'm at, where I should begin, before I begin. Very nice. Because when I start, I'm going to be starting on my premise alone. But I want to start so that what I'm doing is in your favor. That is why I'm asking you, the week before, did we use these? But no, when I go to the board, you will know. Alright. So, when you download the TikTok app on your phone, you just go on to TikTok. Hopefully there's nothing dirty on my TikTok. Because every time I go on TikTok, some strange thing, even when I'm uploading videos, outrageous things just pop up. You know, TikTok is an awful app though, but we can use it for something good. I'm going to go and attempt it again. Let's see what happens. So we don't see anything loading up at it. Let me just give that 3 seconds. Generally, it comes up a lot quicker than this. Alright, do this. Alright, read it. Alright. 50 seconds. Alright. Does your matters? Good afternoon. I'm fine, thanks. The only this year we just have online classes alone. Okay. Okay, sorry about that. No, it is calculus because I thought you were talking about the CSE C6 students. With calculus is a different ballgame. Now, the amount of work that I'm doing now does not allow me to be taking students one-on-one so easily because I'm really crunch for time. Yes, it is. it. No, because what we do is like working with the additional mathematics, K unit 1, K unit 2, K integrated. And we have calculus modules, but the entire stuff is not on calculus. You're welcome. This the same thing. Alright, go for it. Alright, here it is. Alright? So we're not going on TikTok. You just type in the search. You go to the search. I don't know what the hell is that. So when you go to the search, you type it in because it's in my search because I'm using it sometimes. So you type in Richard James Math Resources Live. And then you click on it. If it is the time for the live, it will come on, but it is good if you subscribe. Yes, so that's the classroom, and that's what we have on the board. So you just get into the classroom and you watch. You can go in and make a comment. You can request to come in and say something, and sometimes I invite the students to come in and talk. Right? So it's a very easy. You are young, so young people generally get along quite well with the app. So today is not that bad. It's not a hurtful day for you to just come and get in, because today is for the students who are advanced. So we are doing some accelerated classes for students who are doing the examination in January. So that's what Tuesday classes are about. You can still learn, but it's not really for the general student. And also, it's good for you to go to TikTok. Why? Because when you go onto my page, you can go onto my profile. When you go onto my profile, Richard James Mathematics University's profile, the current videos will be there. And I just uploaded 20 videos in response to a class that I just completed. So these are the videos, so you can watch them and you'll learn because everything is there. You know what I'm saying? So it is for you to be at home watching on TikTok and also use the app with the uploaded files and follow my instruction, because I'm going to give other instruction about other things that you need to do. What I'm using now is this book. So you see the using on a Monday until it's finished, and on Monday and on a Thursday. And then on a Sunday is a problem solving day. So I will be using this book. Sometimes I'm solving the homework exercises from this book. And when I'm through, I will go to tutorial 1. I'll go to this book, of which the answers are in this book. Right, and if you have both of them already, do you? Right. So it is for you to log on. She's over here? Only you. Okay, where do you live? I know, of course. Okay. So, right, so download the app for TikTok. And you can try it out this evening when you go home. By trying to tell it is not difficult because the logo is on all of my books. So you just type in Richard James, but because the name is so long for TikTok, they just put math. So you just type in Richard James Math Resources Live, and you can just get in. So I would suggest that although it's not really a class that is set for you, but you can still learn, and then it will be a good opportunity for you to try. So try and download the app and then log on. Okay, so the classes are going to be Sunday, Monday, Tuesday, and Thursday at 6 p.m. And it's supposed to be live online. As you see, the class is reduced to a book factory. Yeah, and you don't see anything in the next week or two. The work is to be covered up with paper everywhere. So we can hardly accommodate students. That's fine. The information is given you is okay. Okay, you don't need any other information. You think it's fine? Yes. Okay. Okay. Okay, so students, from the week before, did we make use of these formulae? That's the question that I've been asking. All right? No response? Then I know exactly what to do then. Yeah, this may go. Okay, goodbye. All right, so go to your instructional manual, go to page 23, exercise 3D is in the second third of the paper. In the second third of the page. So go all the way to exercise 3D. That is where we will begin. Right. So for exercise 3D, we have A. This one is done for you in the book, but I'm going to do so that I can explain it to you. 2, -6. What we need to do with those 2 points, we need to determine the equation of the straight line that passes through those 2 points. Determine the equation of the straight line that passes through those 2 points. Determine the equation of the straight line that passes through those 2 points. Let's go. The first thing that we need to do is find the gradient. So m is equal to y2 minus y1 over x2 minus x1. So y2 minus y1, y2, -6, minus y1, -3 minus 3, that is, all over x2 minus, let us write it over. I need to have an eraser. All over x2 minus x1. So it is y2 minus y1 over x2 minus x1. -9 over 3. So m is equal to -3. Now we need to find the equation of a straight line. And of course we have 2 methods for finding the equation of a straight line. Y is equal to mx plus c, which is your favorite, and my favorite is y minus the value of y is equal to gradient x minus the value of x. So let me say y is equal to mx plus c. I'm going to use the first point. I'm using the first point. Y is equal to mx plus c. So for this pair of coordinates, we have an x value and a y value. An x value and a y value. So what do we say? Y is equal to m x plus c. So y is equal to mx. So this is the value of m. Y is equal to mx. See? M, the value of m, and the value of x plus c. So y is equal to mx plus c. What are we doing? We are attempting to find the value of c. So of course you'll see that this 3 is equal to 3 plus c. If we have a 3 here and a 3 here, then this has to be 0 for both sides to be equal. Just use common sense. We have a 3 on the left hand side, all by itself. On the right hand side, we have 3 plus something. So if they are going to be equal, the 2 sides are going to be equal, then what we are adding to 3 here must be 0 for it still to be equal to 3. So c is equal to 0. And the equation of your line is what? Y is equal to m x plus c. C is going to be 0, so we do not have to add it. We may do it like that. Then we may use y minus the value of y. And I'm going to use y minus the value of y. I'm going to write it here. Y minus the value of y is equal to gradient x minus the value of x. So we're going to use it right here, and I'm going to use this point. So y minus, remember that a point is a pair of coordinates that represent the point right there. And then what? I have a pair of coordinates. So we have y minus the value of y. The value of y is negative 6. We are using this point now. Y minus the value of y is equal to gradient x minus the value of x is 2. So what do we say? Y plus 6 is equal to negative 3x. Negative times negative is positive, and 3, 2, 6. Right, if we minus 6 from both sides, we'll end up with y is equal to 3x as before. So whether we use y is equal to mx plus c, or y minus the value of y, and whether we use the first point or the second point, everything will be A-OK. Alright, so that is the one that is in the book. I've explained it. Now we have 2 more. So I'm going to put them where, if I put them, you will see. I'm going to put them above that bright light there. 5, 4, 6, 2. 5, 4 with 6, 2. And 1, 2 with 3, 1. So we have 2 of them. So we have this and this. Pick one, and I will do that one. The one that you pick, I will do it. And then you will do the other one. So let's go. Let's go, let's go, let's go, let's go. The one that you pick one and give it to me for me to do on the board. And then you will have to do the other one. Let's go. So just put it in the chat, the one that I should do. Let's see. Good evening. I see someone saying good evening, so I'm saying good evening again. So no one is saying which one I should do? No problem, I will do any one. Let's go. So we're going to find the gradient. We're going to find the gradient. What's the gradient? The last time I did what? y2 minus y1 over x2 minus x1. I'm going to do the other way around. I'm going to do y1 minus y2. So I go to say y1 minus y2. I'm going to write gradient is equal to. Gradient is equal to y2 minus y1 over x, y1 minus y2. Yes, it's y1 minus y2. y1 minus y2, 4 minus 2, over x1 minus x2, over 5 minus 6. I'm sure that you don't hear individuals saying that the gradient is equal to that. But as long as you are consistent, it will yield the same result. You can switch it around on your own and see. The book that we used on a Tuesday, you know that already. For the students who are here, know that this one. Functions part 1. Yes, this one is functions part 1. Functions part 1 is the book that we are using. And I am on page 23. Yes, page 23. So what is the gradient? Y negative gradient. M is equal to 2 over negative 1. So the gradient is equal to 2. Is equal to negative 2. Suppose I put it the other way around. 4 minus 2 over 6, yes, it will still be negative 2. No problem. So I'm going to take this point and I'm going to use y minus the value of y. Let's go. Y minus the value of y. Y minus the value of y is 4 is equal to gradient x minus the value of x, which is 5. Right. So we can do it like this. Y is equal to negative 2x plus 10. Of course, we are subtracting 4 here. We will eliminate this negative 4 by addition. Plus 4. So we have y is equal to negative 2x plus 14. Right, and I'm going to use y is equal to mx plus c over here. Right, so I'm going to be using y is equal to mx plus c over here. And I'm going to be using it with this point. Y is equal to mx plus c. So the value of y is 2. Y is equal to m. The gradient we calculated it to be a negative 2. Y is equal to m. X 6 plus c. So we have 2 is equal to negative 12 plus c. To eliminate this negative 12, we are going to add 12. And we're going to add it to the other side also. So 2 plus 12 is equal to c. So c is equal to 14. And we may finish up by saying what? Y is equal to m, which is negative 2x plus 14. Just like we have it right there. In the meantime, you are going to do this one. 1, 2, 3, 1. Let's go. First thing that you need to do is find the gradient. And this one is horrible because it's not horrible in terms, because maybe it's horrible for you, but for me, it's regular numbers, although they are fractions. Regular, no. Let's go. These 2 points. Gradient. M is equal to y2 minus y1, 1 minus 2 over y2 minus y1 over x2 minus x1. Something is wrong. x2 minus x1. x1 is 1. So what will we have? A negative a half. Nice. Why a negative a half? 1 minus 2 is negative 1. 3 minus 1 is 2. So that's going to give you a negative 1 over 2. Students, you know that exercising good manners for mathematics, you should not write a negative denominator. Right? So you could put the negative sign anywhere except in the denominator. But let's continue. Y minus the value of y, and I'm going to use that with the first equation, y minus the value of y. The y value for the first point, this is the one that we are using first. 1, 2. So we're going to have what? Y minus 2 is equal to, y minus the value of y is equal to gradient x minus 1. Excellent. So what do we say? Y is equal to, we're going to let the negative 2 stay over there. We're going to put it over there. Negative a half x plus a half. Because these have a denominator of 2, then we can write this with a denominator of 2. Right? So 2 is actually 4 over 2. So this is going to be a negative 4 over 2. Right, so that one is a negative 4 over 2. It's the same negative 2, but it is written with a denominator of 2 in order to make the addition easy. So the negative 4 over 2 is still negative 2, but it is written with a denominator of 2 so that it is more compatible for addition with the others. I mean, you get to that point and didn't know what to do next. Alright, well, we're going to use the next one. Y is equal to mx plus c, and you will know what to do next. Of course, you have here negative 4 over 2. So we're going to eliminate that by addition, negative a half. So we're going to have a positive a half here, and when we eliminate this negative 4 over 2, it will be a positive 4 over 2. So we can write that down in one step, positive 5 over 2. Because this will be when we eliminate that and add of course we're going to be adding 4 over 2 to both sides. So we are going to have 1 over 2, which is a half, plus 4 over 2, so that will give us 5 over 2, and then that's all there is to it. The audio is delayed. Well, of course, you must expect it to be delayed, but sometimes it's delayed more than you would like. It is delayed more than we would like. Where did I put that data statement? Alright, so let us continue. It's at its rightful place. Let's continue. Y is equal to mx plus c. So we're going to use y is equal to mx plus c with this one. Of course, the value of y is 1. The value of x is 3. So y, which is 1, is equal to m, which is negative a half. What is x? X is 3 plus c. And of course, students, because we're going to be operating in halves, then we can convert that to halves also. So 1 is 2 halves, right? 1, so instead of 1, we put 2 over 2. And that's equal to negative 3 over 2 plus c. And what are we going to do next? What are we going to do next apart from nothing? So we're going to add 3 over 2 to both sides, thereby eliminating the negative 3 over 2 from this side, and 3 over 2 will be added on the other side. So we're adding 3 over 2 to both sides. So let me just do that. 2 over 2 plus 3 over 2 is equal to c. So c is equal to, of course, because we have the same denominator, it is easy to add 5 over 2. And the equation of a straight line will be y is equal to m x plus c. Bing, that's your favorite. What are we going to do next? What will we do next, apart from nothing? Let's go. The next thing that we are going to do is take a look at the relationship between two perpendicular lines. That one is very nice. Two perpendicular lines. But I think that I will erase that from the board first. We're going to be taking a look at the relationship between two perpendicular lines. If two lines are perpendicular, when we multiply their gradients, the result is negative 1. If two lines are perpendicular, when we multiply their gradients, the result is negative 1. If two lines are perpendicular, when we multiply their gradients, the result is negative 1. Let's go. So let's say we have a line with gradient 5 over 7. What will be the one that is perpendicular to it? So the first line has gradient 5 over 7. What will be the gradient of the one that is perpendicular to it? I need to know the gradient. This one is 5 over 7. What will be the gradient of the one that is perpendicular to it? For the one that is perpendicular to it, when you multiply this gradient, which is 5 over 7, by the other one, the answer that you will get is negative 1. So So you need to tell me what the other gradient is. So 5 over 7 multiplied by the other gradient, and the result is negative 1. What will be the other gradient? Anybody to give an answer? Anyone to give an answer? I'm waiting. I'm still waiting. No suggestion of an answer? That's nice, man. What is the number? Students, you have to make an attempt. If it is only one. Students, when I put the exercise on the board and you don't tell me any, you don't give me any answer, I'm not going to give you any answer either. So if you don't give me any answer whether they're wrong or right, I'm not giving you any answer whether it's wrong or right. So, make an attempt at this. This one is not so critical. The others that I put on the board will be critical though. This is the gradient of the line. We want the gradient of the line that is perpendicular to this one. And of course, when we multiply the two gradients, the result is negative 1. Okay. Oh, did we put 5 over 7? Five over 7. No problem. So the one that is perpendicular to it, when you multiply by this one, you will get what? A negative 1. Therefore, the gradient for the next one has to be a negative 7 over 5. I'm here. So let's go. That's it. So we are going to write down the gradient of the one that is perpendicular to it. So let me see what would be the answer for this one. The one that is perpendicular to 9 over 2. I'm looking at the chat if I can find any response. So I think that I'm going to monitor that. Okay. All right. Now, we have another exercise to do. All right, so let me say it now. Because of the big delay that I notice, I'm going to close and restart. So just be reminded of that. I'm going to close and restart because there's too much of a great delay. If you have that delay again, then of course you know that you're going to use this. For those who are interested. Let's go. So after a few seconds, I'm going to close down and restart. Functions f and g are defined by the function Okay, so this one looks a little bit closer in terms of the time. Alright, so let's go straight ahead. Of course, we have those and the ones that are perpendicular already, so we'll move to the next topic, the next subtopic, or the next exercise. Alright, so we will go into the instructional manual again. So I'm into your instructional manual, not this one. Right, so this one. And there's an exercise there. It has 3 parts. Yes, it has three parts. So the first part is given the points 3, -5, and 7, 3. Find the equation of the straight line that passes through those 2 points. So that's the first part. Find the equation of the line that passes through those 2 points. And of course, you know what to do first. The first thing that you'll do first is find the gradient. Right, so let's go. Find the gradient. Gradient is equal to y2 minus y1 over x2 minus x1. 8 to be divided by 4, and that is equal to 2. So that's your gradient. After finding the gradient, you may find the equation of the line. Use y is equal to mx plus c with this. Y is equal to m x plus c. So 3 is equal to 14 plus c. So c is equal to -11. So the equation of that line is y is equal to m x plus c. That's the equation of the straight line. Now you're going to go to the next portion of the exercise, which is, I don't see anything there, -2, 4. So, -2, 4. What do we say about this -2, 4? The line passes through -2, 4 and is not perpendicular on this occasion, is parallel. Parallel, not perpendicular. So the line passes through -2, 4 and is parallel. Is parallel to the first one. So the line that we are talking about here is parallel to the one that we have just worked with over here. What do we say? If they are parallel, they will have exactly the same gradient. Parallel lines will slope or go in the same direction. They will slope in the same way. They go in the same direction. So parallel lines have the same gradient. Parallel lines have the same gradient. So the gradient for this one will be the same as this because they are parallel. As a matter of fact, I'm not pulling a rabbit out of a hat. We are at exercise 3F. And we are looking at part B. Exercise 3F. And we are looking at part B. Exercise 3F, part B. So the gradient will be the same since they are parallel. Since they are parallel, the gradient will be the same. So we may go straight ahead. This time I'm going to use y minus the value of y. So y minus the value of y is equal to gradient x minus the value of x. So what do we say? Y minus 4 is equal to 2 times x plus 2. So y is equal to 2x plus 4. 2 2 is 4. And this 4 that we are going to be eliminating by adding 4 plus 4. So y is equal to 2x plus 8. Yes, y is equal to 2x plus 8. Now, the third one that we're going to put up there, let us put the points. This one is not disastrous. It's just that you have to use fraction 1 negative 3. So, I'm going straight according to the, oh my, I don't think that you'll be able to see that. 1 negative 3. Right. Yeah, 1 negative, yes, 1 negative 3. Now for 1 negative 3, let me say that again from the beginning. The first one, we found the gradient and used it to find the equation of a straight line. The second one, we did not have to find the gradient because we know that it is parallel to the first one, so it will have the same gradient. So because it's parallel to the first one, the gradient is the same. So we're going to use the same gradient with the point that was given to us. Then when we move to the third one, it is going to be perpendicular to the other two. So because it is perpendicular to the other two, how do we find the gradient? Remember that the gradient, which is 2, for the one perpendicular, you should use a number for the gradient such that when you multiply this and the other number, the result is negative 1 that you shied away from. Nice. So the gradient that is perpendicular to this one and this one, since these two are parallel and the other one is perpendicular to these two, the gradient is negative a half. Right, so the gradient is negative a half. The gradient is negative a half. No problem. So let us find the equation. What did we use here? Y minus the value of y. We're going to use y is equal to mx plus c here. Y is negative 3 is equal to m negative a half. X is 1 and then plus c. So we're going to have what? Negative 6 over 2 is equal to negative 1 over 2 plus c. Student, negative 3 is the same thing as negative 6 over 2. They are identically equal. We're just writing in that form so that we have the same denominator so that the process may be simplified. Nice. So, what do we say for this? We're going to add half to both sides. When we add half to both sides, I'm going to do it literally. Negative 6 over 2 plus 1 over 2 is equal to c. So c is equal to negative 6 plus 1. Negative 6 plus 1. See? You cannot hide away from your directed numbers. No, you cannot hide away from your directed numbers. So we have negative 6 over 2 plus a half is equal to a negative 5 over 2. Your directed numbers are here to stay. So the equation of the line will be what? Y is equal to m negative a half x plus c. c is negative 5 over 2. minus 5 over 2. So that is that. Nice. We are going to look all right. We're going to look at special lines. We're going to finish up with special lines. And lines that are related to each other. So we're going to begin with the equation of the x-axis. We're going to begin our special line with the equation of the x-axis. Now, of course, apart from that, the fact that this can be done in a mathematically sophisticated way, we may do it in a simple way also. That line, which is called the x-axis, it has a very nice simple equation. Every point on the x-axis. So if you put a point on the x-axis at 5, the pair of coordinates will be 5 for the x and 0 for the y. And if you put another one here, at 2, it will be 2 for the x and 0 for the y. And if you put one over here, at -4, it will be -4 for the x and 0 for the y. So there is no doubt that the equation of the x-axis could have something to do with the value of y, which is always 0. So the equation of the x-axis is y is equal to 0. And we are going to put some other lines there. So this one is 3 for the, and this one is 5. What will be the equation of those lines? The equation of the x-axis is y is equal to 0. Everywhere on this line, the value of y is 0. Everywhere on this line, the value of y is, you can see. So what would be the equation of that line? Surely, the equation of this line will be y is equal to 3. All the way down here, y is equal to -7. And of course, you'll be able to tell me what the others will be. Y is equal to 5, as in positive y, 5, and y is equal to -5 right here. No problem. So, as a matter of fact, when I put those up there for the x-axis, not the x-axis, the y-axis, you'll be able to tell me what the equation of those lines are. Let's take a go. If the equation of the x-axis is y is equal to 0, what would be the equation of the y-axis? What will be the equation of the y-axis first? So the y-axis will have equation x is equal to 0. And of course the others, this one will be x is equal to 4. This one is x is equal to 9. And this one is x is equal to negative 2. And this one is x is equal to negative 7. So those are the lines and how they are related to each other. Long time. That could have never happened. Alright. So that's that for that. Any more special line? Yeah. Ready? I think that I saw some special lines. Okay, let's go. That don't look straight is up there. That's a little bit better. So that's it. So that is our first line. And what do we say about that line? Everywhere on that line. So that say that point. That point is 1 here and 1 there. So the pair of coordinates will be 1, 1. Hopefully you can see that. Then this one is about all the way up there. So this one will pass through 3 here and pass through 3 here. So that point is 3, 3. So this point, okay, first of all, let us consider this one. Negative 2, negative 2. So this point is negative 2, negative 2. Notice that this line that we have here, this one, it passes through 3, 3. It passes through 1, 1. It passes through negative 2, negative 2. The equation of that line is therefore what? This one, y is equal to x. Y is equal to x. If you put x is equal to y, yes, if you put x is equal to y, the equation of the line is still correct. If you put x is equal to y, symbolically, it is still correct. But as it pertains to the significance of x and y in a function, then you will have some difficulty right there. But sometimes you don't give consideration to that. Neither do expositors, neither do examiners, neither do instructors or students. So it does not seem to be such a horrible thing. But it's really terrible if you look on the intents and purposes of x and y, where x is supposed to be independent and y is dependent on x. So really, y is equal to x, and not the other way around. And of course, you also have to give consideration to the fact that the equal sign is not a two-way sign. The equal sign is a one-way sign. Right? Later on, when you do additional mathematics and CAPE Unit 1, CAPE Unit 2, you'll know about another sign. Y plus x all squared. Y squared plus 2xy plus y squared. So yes, this one means identically equal to. And that one is the two-way sign. The equal sign is a one-way sign. But the identically equal to is a two-way sign. And additionally, x is independent, but y is dependent on x. So as a matter of fact, to be conclusive, the expression is most appropriately written that way. And of course, intermediately, when you are using an intermediate step, you may write it anyhow. You may write x is equal to y as a part of a process. But at the end, you have to say y is equal to x. So this line, y is equal to x. If you take a look at the other line, it passes through negative 2, 2. So it passes through negative 2, 2. And at the other extreme, it passes through 3, negative 3. So you can see that while these values are exactly the same, these are additive inverses of each other. So we say for that, y is equal to negative x. So this equation is y is equal to negative x. So this diagonal line like that, y is equal to negative x. This one, y is equal to x. And this, of course, these are very significant because later on you will discover that you did functions and the inverse of a function, right? So we did functions and invert functions. Did we? Yes, we did. So you need to understand that if you have a graph of a function and its inverse, they will be mirror images of each other, with the mirror line being the line y is equal to x. Stuff like that. So everything that you do in mathematics will have far-reaching consequence. You will have to apply later on in a significant way. Now, is there any other special line or set of lines or whatever we need to say with lines? Yes, we do. All of the lines that we're going to put in each set, all of them are parallel to each other. But I'm not going to be using the same constant necessarily. Y is equal to 3 over 2x plus 2. Let's say all of those lines are parallel. This is 1. This is 4. I'm going to write it bigger over here. And that is 1. This is negative 4. This is negative 8. Now, since all of the lines are parallel, we can write down the equation of one, and then we'll know the equation of the others. So this one is y is equal to 3 over 2x plus 4. Y is equal to 3 over 2x plus 4. So we're going to write down the others. Now, because they are parallel, they have the same gradient. And if the equation of the line is in the form y is equal to mx plus c, then this is the gradient. The coefficient of x is the gradient. So the gradient is the coefficient of x. That's what it is. The gradient is the coefficient of x. If it is in the form y is equal to mx plus c. And of course, c is where it crosses the y-axis. So that's why we have plus 4. So the gradient, y is equal to gradient plus c. Y is equal to mx plus c. So what is the equation of this one? That one passes through y is equal to a positive 1. So we say that what? That one. So this one is y is equal to, the gradient is the same, 3 over 2x plus 1. The gradient is the same. This one, what's the equation of this one? All of them, the gradients will be the same for every single one. They are parallel, so the gradient part is equal. Y is equal to 3 over 2. That's the gradient part. The coefficient of x plus where it crosses the y-axis is not plus 8, as you see, but negative 8. This evening I have to be on my P's and Q's more than any other time because the students are not responding. All right. So what do we say next? This one, what's the equation of that one? Y is equal to 3 over 2x minus 4. The gradient part is the same, only the y-intercept is different. Now, we're going to write another set. Flat. I'm going to do this one. I'm going to write this different from the one in the resource, in the manual. Let's say all of them are parallel. There you go. So I'm going to write down the equation of 1. You take on the rest. Y is equal to negative 2 over 7x minus 3. Y is equal to negative 2 over 7x minus 3. Well, let's see if it is the same. Then Alright, so let's go. So the others will be, of course the gradient will be the same. Y is equal to negative 2 over 7x plus 3. Y is equal to negative 2 over 7x minus 6. And finally, y is equal to negative 2 over 7x. That's how it is. So after that, what do we say? Nothing. I'm going to look inside of this book. No, not that one, this one. And of course, now students, 1 year I asked the students to find the gradient of something. So the upper line, of course, the students were given all kind of answer. And one of the students said to me, Mr. James, is this correct? And I said, no. And the student said, what is the correct answer? And I said, I don't know because I have not calculated it. Then the student said, oh, Mr. James, if you do not know what the correct answer is, how do you know that my answer is incorrect? Right? If you don't know what the correct answer is, how do you know that my answer is incorrect? So I told the student that from the way that the line slopes, the gradient is negative, but you gave me a positive answer. So it cannot be right. So if you have a straight line and it slopes like when you lift your right hand like that, if the straight line slopes like that, then that is a positive slope. Right, so if the line slopes like that, when you lift your right hand, then that is a positive slope. On the other hand, if it slopes like this, like when you raise your left hand, then that is a negative slope. Of course, that's a rule of thumb. But it is not always good to just say it like that without any proof or without any logical purpose. Now, conventionally, when you progress from left to right, you are moving in a positive direction. And we should consider a positive movement when we consider how a line slopes. So you don't say that this line, the way that this line is sloping, you say it is sloping like this, student. And the way this one is sloping, you don't say that it is sloping like that. You say it slopes like that. Because at all times, you should be going in that direction for the x. The x value should be going like this. And you know that the gradient is the change in y over the change in x. The movement from left to right like that for the x value is always a positive movement. So you're working out your gradient based on a positive movement for x. So you are going in this direction like that. As you are going in this direction, what do you notice? The value of y is going up. Y is increasing. And because y is increasing, the gradient of that line is positive. So while you're going in that direction for the x, the change in y with respect to x is positive. So as x increases, y goes up. That's a positive gradient. But if you look at this one, give it a little more length. When you're going in that direction, it is going like this, meaning that the value of y is getting less and less each time. So because the value of y is going down as you are increasing the value of x, the gradient is negative. That is all for that. And the rule of thumb is that when your right hand goes up, that's a positive slope. When your left hand goes up, that's a negative slope, when it slopes like that. And of course, we have completed that one. Okay. Now students, this class is your last Tuesday class. I am not getting any feedback from the class, so I'm going to give you a set of lessons that do not require feedback and conversation. I wanted to say something to the students to hear how they are thinking, how they are approaching the problem. Invited you in to speak. Everybody declined. I don't see any answer coming up there. So I'm going to give you some lessons that you do not you do not need any interaction. By Sunday, you will see where they are available, so you can watch them in your own good time. Right? Yes. That's what I'm going to do for you. You can watch them 1,000 times. You can go over. And there's no break in between asking you questions for which you are required to supply an answer, so that we can say, all right, you understand or you do not understand. So that is what I will do. But I'll give you the information by the latest Sunday, or you can access those videos. Of course, they are available on YouTube. And we are going to see if we can also organize some Vimeo videos for you, and Vimeo videos for everyone. Now, the topic after this, well, it should have been gone already. Quadratic graph, and then the one after this is straight line graph. You will get a very beautiful representation of those in the audio visuals. Okay? The hands are not going up as yet. So, thank you very much for your participation. Thank you very much for inviting others. Thank you very much for joining, for sharing, for liking, for everything that makes Richard James Mathematics Resources live on TikTok worth living. So, full-fledged class on Thursday at 6 p.m. sharp again. I should have been on a little earlier, but this TikTok is giving me all in a circle. Okay, so for now, it is when you see the hand goes up, when you see the hands go up, it is goodbye until Thursday. Have a good night's rest, and have a blessed day and a half until we meet again on Thursday at 6 p.m.